Picture a dinosaur reaching for the treetops, its neck stretching stories high, a true titan of the Jurassic landscape. You're likely thinking of Brachiosaurus, one of the most famous and instantly recognizable dinosaurs. But what if I told you the iconic skeleton you might picture, the one towering in Berlin, isn't actually Brachiosaurus? And what if the real Brachiosaurus had secrets about its posture, size, and lifestyle that are even more fascinating? Welcome back, height enthusiasts, to Dinosaur Anatomy. Today, we're craning our necks to examine Brachiosaurus altithorax, the arm lizard with the deep chest. We'll separate fact from fiction, distinguish it from its famous African cousin, explore how it supported that incredible neck, and delve into the latest science surrounding this genuine giant from North America's late Jurassic period, what around 154 to 153 million years ago. Let's start with the name. Brachiosaurus means arm lizard. Why? Because its most distinctive feature, identified by its discoverer Elmer Riggs in 1903, was its incredibly long forelimbs. Unlike most dinosaurs, and virtually all other sauropods like Diplodocus or Apatosaurus, Brachiosaurus's front legs were significantly longer than its hind legs. This gave it a built-in upward slope, with its shoulders towering high above its hips, making its back slant downwards towards the tail. This giraffe-like posture is unique among sauropods and is central to understanding Brachiosaurus. This posture immediately suggests its ecological niche, high browsing. With its shoulders already elevated, Brachiosaurus could reach vegetation, far higher than other herbivores in its environment. Its neck, while incredibly long, perhaps reaching 30 feet or more, didn't need to be held completely vertical like a modern giraffe's to access these high food sources. Which brings us to the great neck posture debate. For years, depictions showed Brachiosaurus holding its neck almost straight up. However, studies looking at the neck vertebrae, cervicals, and the immense physiological challenges of pumping blood that high against gravity have led to revised thinking. Researchers like Stevens and Parrish initially suggested a more horizontal posture based on computer modeling of vertebrae articulation. However, others, including Michael Taylor and Matt Weddell, have argued that the vertebrae could support a more elevated posture, perhaps around 45 to 60 degrees, and that the associated soft tissues, ligaments, muscles, would have played a crucial role. The consensus today leans towards Brachiosaurus holding its neck significantly more upright than Diplodocids, which likely held theirs more horizontally, but probably not ramrod straight. It achieved its feeding height through a combination of its elevated shoulders and a steeply inclined, though not perfectly vertical neck. Imagine the complex network of muscles and ligaments, including a massive nuchal ligament like those in horses, needed to support such a structure. How big was the real Brachiosaurus? Brachiosaurus altithorax, known from fossils found in the Morrison Formation of Colorado and Utah, was truly enormous. Estimates based on the available material, which is less complete than its African cousin, suggest lengths of around 70-80 feet, 21 to 24 meters, and potential weights in the realm of 50-60 tons, possibly more. While undeniably massive, it might not hold the title of largest dinosaur ever, as some other titanosaurs might have been heavier or longer. Still, it was certainly one of the giants of its time. Let's look at the head and feeding. Brachiosaurus had a relatively distinctive skull for a sauropod, with a high arched snout featuring large nasal openings high up on the skull, above the eyes. For years, this led to the popular, but incorrect, snorkel theory, that Brachiosaurus lived in water and used these high nostrils to breathe. Paleontologists have thoroughly debunked this. Sauropods were terrestrial animals, and the water, pressure at depth would have crushed their lungs. The function of these high, large nasal openings is still debated, perhaps related to vocalization, housing soft tissue structures for display, or thermoregulation, or enhancing the sense of smell. Its teeth were broad and spatulate, spoon-shaped, suitable for stripping leaves and vegetation from branches. Like other sauropods, it didn't chew its food. It swallowed large quantities, relying on its massive gut and likely fermentation aided by microbes to break down the tough plant material. Now, let's address the elephant, or rather, the Giraffatitan in the room. The spectacular, near-complete sauropod skeleton, mounted in the Museum für Naturkunde in Berlin, often labeled as Brachiosaurus, is actually a different genus, Giraffatitan branchi. Fossils of Giraffatitan were found in Tanzania, Africa, from slightly younger rocks. While closely related and sharing the long forelimb characteristic, detailed anatomical studies, particularly by Michael Taylor in 2009, highlighted significant differences in the vertebrae, proportions, and overall build, justifying their separation into distinct genera. The real Brachiosaurus, B. altithorax, is known from less complete remains found only in North America. So, while Giraffatitan gives us a great visual for a brachiosaurid, it's technically not the same animal Riggs discovered. Life for Brachiosaurus unfolded in the famous Morrison Formation ecosystem, a semi-arid environment with floodplain rivers and forests of conifers, cycads, and ferns. It shared this world with other giants like Diplodocus, Apatosaurus, and Camarasaurus, armored dinosaurs like Stegosaurus, and predators like Allosaurus and Torvosaurus. Its unique high-browsing strategy likely minimized direct food competition with the lower-browsing Diplodocids and Camarasaurids. However, young or weakened Brachiosaurus would certainly have been vulnerable to the large theropods of the time. Let's recap some key points and myths. Fact: forelimbs longer than hindlimbs, creating an upward sloping back. Fact: a high browser, likely holding its neck at a steep incline, but probably not fully vertical. Fact: known from the Morrison Formation of North America. Myth: the Berlin skeleton is Brachiosaurus altithorax. Reality: it's Giraffatitan branchi from Africa. They are distinct genera. Myth: nostrils on top of the head acted as a snorkel for underwater life. Reality: terrestrial animal. Nostril function debated. Smell, display, thermoregulation. Fact: its teeth were spatulate, designed for stripping vegetation, not chewing. Brachiosaurus altithorax, discovered by Elmer Riggs and described in 1903, represents a unique evolutionary path among sauropods. Its distinct body plan, optimized for reaching high vegetation, made it a towering presence in the Jurassic landscape. While often overshadowed in popular culture by its more completely known African cousin, the true North American Brachiosaurus remains a pivotal discovery, showcasing the incredible diversity and specialization within the largest group of animals to ever walk the earth. What unanswered question about Brachiosaurus intrigues you the most? Its exact neck posture? The function of its nasal openings? Let me know below. If you enjoyed reaching new heights with this iconic sauropod, please elevate that like button, subscribe to Dinosaur Anatomy, and ring the notification bell for more deep dives into the world of giants. Thanks for watching.